The problem statement that I propose is focused on analyzing quite an extensive amount of the satellite data over the last 15 to 30 years, probably depending on the quality, and try to find the indicators of the climate warming that we see in the Arctic on the satellite images, create those time series. So the whole idea is that the climate change is real, right? And it's accelerating over the last 10, 15 years due to the anthropogenic effect. And Arctic is warming at least 2 times faster than the rest of the world. And we know that it happens, but there are different indicators of that. One of the indicators is thawing permafrost. So permafrost occupies extensive regions in the Arctic, thousands of miles, kilometers, right? And even slight changes of the temperature, like fractions of a degree, can actually produce a huge effect. Thawing permafrost reshapes the landscapes, right? It creates those craters. They're called thermokarst landscapes. One of those features that we observed recently are a large thermokarst crater, because when permafrost, its integrity is disrupted, all the gas, organic carbon, which is stored in the form of methane gas, gets released into the atmosphere, and this process is very rapid. It can happen on a matter of hours to days. So my idea is to try to map those craters as they generate. For example, we're looking at satellite images from September or June 2015, and there is flat ground, nothing in the satellite image. But then we're looking at the next satellite image over the same area, let's say it's September 2015, and we see there is a hole in the ground, right? And a couple of months later, this hole fills up with water, and we see there is a thermokarst lake. So the challenge is to map those thermokarst lakes or craters over the timeline of 15 to 20 years, depending on the data quality, and then try to map them and catalog them. And we know that the first crater that have appeared about 2013, after the warmest year on the record. And since then, we've been mapping tens of them over the last 10 years, and there's enough time to try to draw some trends, right? And see if the amount of these craters is increasing or decreasing, or is the same, and try to compare it with the temperature data and probably put on the forward climate models.